Hello, 8th grade science. These are the directions for the Newton's third law Jamboard. So you're going to find that assignment on Google Classroom. And traditionally, we actually, the in-person kids probably will still, but there's an assignment that I have you do before this, but I decided to scratch it for you guys because I made a note this year, COVID year, that it didn't work. So it's actually you're welcome. But you guys are going to miss one crucial detail that I'm going to explain a little bit in the directions, so make sure you're listening. When you get this open, and I look at all these slides here, they're kind of broken into part by color. So the first part is green, second part is blue, and then there's only for the last part here, and that's yellow. But let's go over through what each part is asking you to do. So on this first part, the green part, your goal or your job is to identify action and reaction forces. Now, this is the part you probably don't know about what they are yet. Action and reaction forces are just pairs of forces according to Newton's third law. So Newton's third law said for every action, there's an equal and opposite reaction. So we're trying to figure out what those forces are in these different examples. A really good example that we often talk about is like gravity and the normal force. Gravity pulls down, the normal force pulls up. They're equal, they're opposite, action reaction forces. Okay. So the directions for the green part one here, is they're going to use this picture, this GIF, to identify the action and reaction forces on the object. And I kind of clarified the object because sometimes kids get a little confused as to what they're supposed to be focusing on. In this case, it's just Baby Yoda standing there. So you're trying to figure out what would be an action force and what is a reaction force for Baby Yoda standing on there. A lot of times you can use gravity as the action force and the normal force as your reaction force. Gravity's pulling you down, the normal force is holding you up. Some kids can do the cup too if you really want, right? His force is moving the cup up to his hands, and then the reaction force could be the cup, applying a force back on his hand. That's why you kind of feel the weight of things, is because there's a force, they're applying a force to you as you apply a force to them. So that's kind of the green part. The next example, it's him flipping the switch here. So it's when he's actually pushing on the switch. You can find the action reaction. This one is them clapping their hands together. Now, some kids get confused with this. Focus on like one hand as the object, not both, because those could almost be like two different ones and they get confused. If it helps in my head, I always just hold one hand like not moving, and then I take the other one and I hit it. And that, I don't know, it helps picture it for me, and it has helped some kids in the past. And then the last one is just them sitting in the chair. Okay, that's part one. Part two, I've had kids in the past, students, ask questions of, so if the forces are equal and opposite, like Newton's third law says, how is there any motion? How is there any movement when they're equal and opposite? And that's what I kind of want to tackle with this part. So what you're going to do is you're going to try and list the forces that are acting on that object, and then try and explain how that object is moving. I'll kind of talk you through it a little bit actually right now, just to save you some time. So in this case, I'm not going to help you with listing the objects on this first one. I think you guys are really good by now at listing forces, knowing the forces, diagramming those, etc. So list those 4 forces. And then the question is, if the forces are equal and opposite, how does it move? And so I actually have a hidden hint behind this thing. See that? Isn't that cool? So here's my hint that'll kind of help you, and this will be on yours too. So you, as in these little people, right, maybe pushing on the anchor, but remember that the anchor is not pushing on, the anchor is pushing on you, not on itself. So when you push on an object, in this case the anchor, right, you would think that there should be an equal and opposite reaction, and there is, but it's not back on the anchor. It's on a different object. In this case, it's on you. If it helps, let me do a diagram. So for example, here's my force diagram of the anchor. And I'm only going to draw just the push for right now, okay? This is the force of the people pushing on the anchor, okay? Now, what some kids think then, okay, this is the force of them being pushed, then the equal opposite has to be on the same thing, on the same object, and then there shouldn't be any motion, right? That's wrong. There is no reaction force on the anchor. The anchor is not going to push back on itself. It's going to push back on the humans, which are a different object. Okay, so if this is my anchor, I'm trying to do this with my mouse, which is interesting. That's an H. Oh, that's so bad. Okay, this is the anchor, right? With the humans pushing on it. Well, the reaction force, it's on a different object, almost like it would be a different force diagram. In this case, this is I'm just going to call it the reaction. Ooh, can I write that? Ooh, that might be ugly. It's not that bad. I feel like my handwriting is actually better this way. Right, so the reaction force is on a different object. So the action force is on one object, the reaction force is on another, and that's how we actually get movement. If it were on the same, like if the anchor applied a force on itself, then yeah, there wouldn't be any motion. But the anchor doesn't push back on itself; it pushes back on the human. That's why you can feel the weight of something when you push it. So I hope that makes sense. The hint is a little bit wordier. So if you need that, find that. How I got to it, I'll show it to you. Click on the background and then right click, go to order, and then just hit send to back. Okay? All right. So hopefully that makes sense. You're going to do another 2 examples of that. One with skateboarding, one with football. And then the last one, you're just trying to think what would be some ways to reduce the forces in a crash. Kind of talks about here, you'll write your response here. Okay? That's the Jamboard assignment. Good luck. Hopefully it'll make sense. Again, this is kind of one of those areas where if you're really stuck or you're struggling or if it's not making sense, especially that blue part, you need to be reaching out to your teacher. It's really hard for us to know how to help you, especially when you guys are just doing this at home on your own, unless you reach out to us, email us, get a hold of us, post a comment on Google Classroom, whatever. Contact your teacher, and then we can meet with you, talk to you, work it out with you, okay? Make sure you're advocating for yourselves. Have a good rest of your day. Bye.